Part 3, Metabolism and Digestion. What is metabolism? Metabolism represents the sum total of all physical and chemical changes that take place within the body. We can divide it into anabolic and catabolic metabolism, depending on if it's constructive, building, or disintegrating, breaking down. Metabolism can be measured by the total daily energy expenditure. There's the metabolic rate, food and metabolism, and exercise and metabolism. The metabolic rate's how fast or at what rate the body uses its energy stores. There's a basic metabolic rate, one's metabolism at rest and taken after 12 hours of fasting. The resting metabolic rate's the same as the BMR, but not at rest or fasting. It may include previous activity. The REE, or resting energy expenditure, is the RMR plus environmental factors that could alter metabolism, such as being cold. Another comment on metabolism, or energy expenditure, is going to be the thermic effect of food, or TEF, which is usually about 10% of total calories. Exercise metabolism is a third of the energy expenditure. They can be labeled exercise metabolic rate or thermic effect of exercise. These three components will total up to the daily caloric expenditure. The resting activity, or the BMR, is usually the highest burning rate. This chart depicts this, as well as this one. You'll also notice the non-exercise activity there, thermogenesis. Here are the three components again. Let's look specifically at basal metabolism. This is the minimum energy expended to keep a resting, awake body alive. It's usually about 60 to 70% of total energy needs, and needed for maintaining a heartbeat, respiration, and body temperature. There are many influences on basal metabolism. These details will be discussed as we progress through the slides. Physical activity can increase your energy expenditure beyond the BMR. It varies widely among individuals. The more activity, the more energy burn. Remember, lack of activity is the major cause of obesity. Notice the increase in caloric expenditure as the oxygen consumption and effort increases. Remember that the thermic effect of food is the energy used to digest, absorb, and metabolize nutrients. The metabolic rate is elevated after a meal. This is dietary-induced thermogenesis. And this is useful sometimes in weight control programs. It's important to know that 5 to 10% of the total calories will be used for metabolizing, so you'll have to add on those extra calories when figuring out your energy expenditure. The TF's higher for carbs and protein than fat, and less energy is used to transfer dietary fat into adipose stores. One way to calculate your daily resting energy expenditure is to take 1 calorie per kilogram of body weight per hour. Another method is to just take your weight in pounds and add a 0. We'll use these charts for class. This is the male and this is the female for estimating RMR. This formula will help you in calculating your resting energy expenditure. Some genetic factors that affect your REE are age, gender, your natural hormone activity, and body surface area. Some environmental factors are cold weather, hot weather, altitude, cigarette smoking, and caffeine. What energy sources are used during rest? The oxygen energy system, aerobic system, prevails during rest. About 60% of energy is from fat and about 40% from carbs, very small amount from protein. Eating a diet rich in carbs or fat will respectively increase energy production from carbohydrates and fat. We looked at resting metabolism and TEF. Now let's look at exercise. Exercise stresses most body systems. How do my muscles influence the amount of energy I can produce during exercise? How is energy used during exercise? Muscle cells utilize the energy provided by fats, carbohydrates, and protein. Muscle fibers can be divided into 3 categories depending on their color and preference of speed of twitching. Type 1, slow oxidative or slow twitch, are usually used during endurance sports and are reddish in color, representing the increased oxygen flow. Type 2A, fast oxidative glycolytic, are pinkish in color and are used during intermediate activities. Type 2B, fast glycolytic or fast twitch, are white and are used in more anaerobic type activities. Muscle fibers are used or recruited generally in the order of SO, then FOG, then FG. Muscle fiber contraction is believed to involve the proteins actin and myosin contracting in the myofibrils, then calcium ions releasing in the sarcoplasm of the cells with nerve impulses that stimulate muscle contraction. This is called the sliding filament theory. Study this chart that shows the characteristics associated with the three types of muscle fibers. Energy into muscular activity. In each cell, energy is used by the removal of a phosphate, remember from ATP to ADP, every time the muscle contracts. At rest, ATP transfers from fat to muscle. When beginning exercise, ATP is generated from CP, remember that's creatine phosphate. At steady state exercise, comfortable but steady aerobic starting at about 5 to 15 minutes into the activity, the cell's fuel comes from carbs from the muscle and liver and fats from the muscle and free fatty acids. This is in the blood, the free fatty acids. The CP pool is resynthesized for later. A mixture of substrates, the use of CP, carbs, or fats, occurs at any one time, and there's no switching at depletion if you run out of one. Muscles will not switch fuel to one that runs out, and running out of glycogen will not lead to a total fat use mode. Fat is energy for most ATP resynthesis because it's so abundant in the body. Now back to muscular exercise and its effect on the metabolic rate. All physical activity increases the metabolic rate. There's the ADL, the activities of daily living, and then there's also the planned exercise activity, which includes exercise metabolic rate and the thermic effect of exercise. Notice as the intensity increases, so does the metabolic rate. In our previous metabolism video, you watched the cyclists in the VO2 max test. This is one way of measuring exercise intensity. You can also do a muscle biopsy. You can also measure the onset of blood lactic acid. Keep in mind that training won't increase your VO2 max substantially, but at what percentage of your VO2 max you can work at. Energy expenditure of exercise metabolism can be expressed in many ways, such as METs, calories, joules. We will only be using calories in this class, but you can look at some of these conversions just so you can become familiar with them. Since a VO2 max test is not real practical for everyone, you could also use heart rate or respiratory rate. Increased heart rate and respiration is going to mean increased oxygen consumption. Charts like this one will help you determine your energy cost of exercise. Generally, activities involving large muscle groups are going to be the best types of energy expenditure activities, such as walking, running, and cycling. Here's a nice chart from your textbook. This breaks the activities down into light, moderate, or heavy types of exercise. Compare the energy expenditures between males and females and between walking and running. Does exercise affect your resting energy expenditure? Yes, there's a metabolic after effect of exercise. The RMR remains elevated after intense exercise, and this is variable depending on how hard you worked out, how long you worked out, etc. There seems to be a minor contribution to how exercise may affect the thermic effect of food. How much energy do you need to consume daily? Well, you're ready to calculate this now that you know the three components. Part of the formula for your assignment involves choosing a PAL, or physical activity level, and then doing the calculations here to get your EER. Here's an example of a sedentary female with a PA of 1.0 and a very active female with a PA of 1.45. You can see the difference in the EERs. See if you can calculate your EER. This concludes Part 3 of Digestion and Metabolism.